So hello and welcome. Howdy. Hope your day is going well. Going to get into another question on LeetCode. It's been like a month since the last time I worked on a problem, but I kind of like to keep my skills like up to date, I guess, or just, I don't know, just keep practicing. I don't like to let too much time pass. Although I have something of an adventure coming up. As if the last month wasn't an adventure already, which those of you who are wondering what was going on, I moved a lot of stuff. Like we're talking a house full of stuff. I learned how to move a refrigerator by myself up and down a ramp. That was interesting. That was terrifying. It was kind of painful too, because of the way I had positioned myself. Excuse me. But here we are. We'll keep solving LeetCode problems. So matchsticks to square. All right, let's take a look at this one. Let's see what we do. Let's see where you can still solve problems in a reasonable way. Given an integer array matchsticks, where matchsticks of I is the length of the ith matchstick. You want to use all the matchsticks to make one square. You should not break any stick, but you can link them up, and each matchstick must be used exactly one time. Return true if you can make this square, and false otherwise. So you want to use all. Excuse me. Make one square, and there's a length for each matchstick, which I guess is an integer, and you need to use all the matchsticks to make one square. Oh, okay, that's very interesting. That's a neat question. So 1, 1, 2, 2, 2, 2, 2, 2, 2, 2, 2, 1, 1. Okay, true. Form a square with length 2. One side of this square came 2 sticks with length 1. So, okay. How I might solve it. Well, something of an idea, but let's read another example. So 3, 3, 3, 3, 3, 4, false. You cannot find a way to form a square with all the matchsticks. So the matchstick's length is going to be between 1 and 15, and the number of matchsticks is going to be between 1 and, it looks like 10 to the 8th. Is that what that says? 10 to the 8th. Whoa, really? Whoa, this is a really interesting question. So actually you need something better than linear time, because 10 to the 8th, is that what that says? Am I seeing that correctly? That might be kind of hard. Whoa. I don't know how you could solve this. Whoa. 10 to the 8th. Really? Are they sorted? Whoa. Uh-oh. No. Really? Oh, I don't know about that. That's a very large number. 10 to the 3rd is 1,000. 10 to the 6th is 1,000,000. This is 100 million. Can you even iterate through all of these? And like, let's just do something really simple. Um, 15 times 10 to the 8th is like 10 to the 9th. 10 to the 9th is, take 2 to the 32nd is like 10 to the 9th. It's close to 10 to the 9th. Yeah. Log 9, and then 2 to the 31st is a little over log 9. Yeah, so we should be able to, I think we could fit this into a single integer. We can make it a long, just want to see if this actually runs on. Wait, what? True. It's not. I don't know if I can I get a test case that has 10 to the 8th? Can I even do that? How would I do that? I don't even know how to do that. Oh boy. Woo, 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 woo. This is kind of a problem because I would think you'd need to know what the value of each matchstick is to be able to solve this problem, right? Because that's basically my problem, is that I don't think you can do this in linear time because this number is way too big. Yeah. Can we get a test case that's that large? How do we even do that? I guess we could try. Sure. Let's do 15, 14, something like this. This is going to be interesting, to say the least. You can multiply by powers of 2 at 30 times. So, 1,000 million billion. We want 10 to the 8th, so we want 100 million. 1,000 million, 10 million, 100 million. Okay. It's a little more than 100 million. It's a couple hundred million. So actually 10 to the 27th would be enough, I think. Yeah. It's actually like this is more. 34 million more. So this is a little bit more than we need. But this should be sufficient. So we need to do this 27 times. So how many times did we do this so far? We have, all right. This is 1, 2, 3, 4, 5. Oops. Well, I forgot how I lost count. 1. This is 2. This is 3. This is 4. This is 5. This is 6. This is 7. 8. 9. This is 10. 11. 12. 13. 14. 15. 16. 17. 18. 19. 20. 21. 22. 23. 24. 25. 26. 27. Okay. So this should be 2 raised to the 27th. We have a lot, right? And we go 1 character here and 1 character there. All right, that's the test case we want to use. Hopefully we can paste that. My whole stream is probably freezing now. Everything's probably freezing. Oh, did it crash the browser? Is that what happened? Is that what happened? I think that's what happened. Let's see. It's full screen for a moment. Browser just crashed. Nice. That's great. Had a problem and crashed. So try to restore your tabs and windows when it restarts. Help us diagnose, fix the problem, and send us a crash report. Nice. Nice. Sweet. Alright, we're gonna restart. Try again. Are we still streaming? We're still live? Encoding overloaded. Alright. Broke the system, man. Broke the system. Let's see, we're still live. I think so. Find out in a minute. Oh, wait, full screen. That's always fun. Alrighty. Is it working? I think so. Pause. Okay. That's fun, man. Okay. So that's super awkward. This is a very awkward situation. The test case is so large that I cannot test whether or not a linear time solution will work on such a large test case because it's so large I can't even input that test case as a possibility, right? The browser will just crash. I know some like interview testing sites have like, excuse me, they have like upload sections where you can upload a file as for a test case. Like HackerRank does that, where you can upload the file. So I can actually create a file that has all that data in there and then upload the file as a test case. I think Premium might have that ability. I didn't anticipate that I would need to use that. I don't know if Premium has that on LeetCode. But yeah, this is it's kind of frustrating. This is a little frustrating because I don't even know if a linear time solution will work. And I think linear time solution might be a lower bound on this. Like if a linear time doesn't work, then I don't know what would or what could. Now, something to be said, if these, it looks like these matchsticks they come in sorted order. If that's true, then you can do this in probably logarithmic time. However, I don't think hopefully possibly logarithmic. Like if they're not sorted, then I think you're just kind of out of luck. Like I don't think you can do a linear time solution on this, just because it's so expensive. I want to say it takes like 10 milliseconds for like 100,000. So if you have 100 million, 1, 2, 3, 4, 5, 6, 7, 8, divided by 100,000, that's like 1,000 times 10 milliseconds gives you 10,000 milliseconds divided by 1,000. Yeah, it's gonna take 10 seconds just to go through all of the values, which means I think it's a lower bound. I don't think you can actually solve this. If it's not sorted initially. The matchsticks of I is the length of the ith matchstick. You want to use all the matchsticks to make one square. You should not break any stick, but you can link them up. Each matchstick must be used exactly one time. You can make this square and false otherwise. This is hard, man. This is hard. This is hard. This is hard. Interesting question, dude. It's a huge input size. That is enormous. At least the matchsticks size themselves is relatively small. But like, if you had the data as just a map of like, you know, a size is 1 to 15 and then how many of those sticks you have, like that, this would be a lot more manageable. But this is it's kind of hard. Like, I don't know how to reconcile this. They're not sorted. Is there example test cases? What does this do? Oh. I don't know, man. It's hard. It's super hard. I don't know how to. Oh, my neck. How about like if they're not sorted? What happens if we do this? Speed up. What is that? Server error. Serious? Excuse me? What? Huh? Well, that's an unusual response. I don't see that too often. One more time? Yeah, okay. Okay. That was weird. I don't know, man. Wow. Oh boy. I don't know, man. I don't know. Oh man. I want to check the discussions to see if there are any, what the runtime is for the solutions they have, because I don't really have a feasible way to check whether or not a linear, like to answer the question, would a linear time solution be too slow? The answer to that question. That's extremely important, because if it's too slow, then I don't think I could solve this problem. So it must be fast enough. But if it's not fast enough, then there'd have to be some condition that allows me to do this faster. But the only condition I could think of is that if the matchsticks were sorted, and so you can quickly determine how many you can do in logarithmic time. You can figure out how many matchsticks of each size you have, and then that's a simple math problem. But if they're not given to you in sorted order, and it doesn't say that these are given to you in sorted order, which is really frustrating. It's the length of the ith matchstick. You want to use them all. Cannot break any. Link them up. Yeah, it doesn't tell you whether or not. It looks like they might be sorted, but if they're not, then it's going to be extremely difficult if they're not sorted, because you have to go through you got to go through the whole array, which has a ton of matchsticks. So this is really hard. I don't know how this can be done. Like, I would need to go through all of the test cases to see if they're sorted or not, the inputs. I think I want to go to the discussion and just see what they say, because I think it's def first search. Serious? Wait a minute, did I misunderstand something? Oh, I'm such a dummy. I'm sorry. I need to get more sleep. I'm so dumb. That's why you gotta practice, man. That's why you gotta practice. The size of the matchsticks are between 1 and 10 to the 8th. The number of matchsticks is between 1 and 15. That's not, oh yeah, you could just do a DFS. Okay, never mind. All right, DFS is fine. Yeah, 15 should be okay. I feel like a dummy now. I was like, how is this possible with that many matchsticks? Like, that's so many. No, the value of the matchstick is between 1 and 2. Oh, dude. That's what happens when you're this happens when you don't get enough sleep and when you haven't practiced in a month. Okay, well, yeah, DFS is pretty straightforward, pretty easy. I actually don't think there's probably not a better answer than that, quite frankly, because this is kind of a hard question. Like, so to actually get to the question itself, basically you'd want to pick a length of side for the for your square, and then you'd want to see if you can group your matchsticks in such a way where you can get 4 groups that are equal to that length. It's like maybe another way of expressing it is if you were to add all of the matchsticks together, right, and then divide by 4. So this would be 2, 4, 6, 8. Add them all together, divide by 4, and then you want 4 groups, 4 disjoint groups that each add to that sum, that value of 4. Which, by the way, if the sum is not divisible by 4, then immediately you can say false, right? So in this case, you have 6, 9, 12, 16. Well, it would have to be 4, but you can't find. Excuse me, you can't find 4 groups of 4 in this case, right? You have 1, 4, and then you can't select two values to get 4 from what you have here, and so you would just be done there. Doesn't actually matter how you create each group, I think, as well. Or that may or may not matter. Well, no, I guess it does, right? Because you could do, like, yeah, no, that does matter. So you could do 1, 1, 1, 1, 3, 4, and you can create a group. You could create a 4 here, create a 4 here, and then you need a 1 for this 3 to become a 4. But I guess you could have a 2 maybe, 2 and a 3 or something. I don't know. Yeah, well, 1 and then 2. Yeah, you could do something like that. 2, 3, 3, 4. So you group this 4 with here, group these 1s with this 2's here, and then group a 1 with a 3 and a 1 with a 3. But if you did 1, 1, 1, 1, and then put that in one group, and then you couldn't, this 2 or 3, 3, 4, you couldn't group these into 8, into 2 groups of 4 appropriately. So it does matter how you group these things. I'm not sure exactly. I guess. I said DFS. How would I set up a DFS for this? Yeah, you could take the sum, divide by 2, you get the total that you're looking for. You want 4 groups of that total. And yeah, I mean, you could probably just brute force depth first search, and say, you have 4 different groups. So you're trying to select the first group, and then once you selected the first group, then you select the next group of 4, and you do that 4 times. actually the last group you don't need to do because it's you could just keep a running total, right? If the what's left over, if you can get the first three groups, you're actually, you have to be done at the end. Like you don't actually need to do the fourth group, so it's only the first three groups. The problem with this is like, this is sort of like going through all of the permutations. And the number of permutations, 15, permutations of 15 are a lot. Right, that's a very large number. 1,000, million, billion, trillion, yeah. Yeah, it's as if you go through all the permutations and throughout the permutations that don't have, where the first few numbers don't add, like, I guess it would be like going through all the not exactly. Well, I guess it's pruning a little bit. Yeah, it's a little bit of pruning. The pruning would be all of this, all of the, I guess, like values that you've put in the front of the permutation that add up to the total we're looking for. You kind of filter on that, and then it's kind of like a natural prune, and that would prune out a lot of different possibilities out the gate. Like there's only a few ways you can get. You do 4, 1, 1, 1, 1, 1, 1, 2, and 1, 3. And these are the only 4 like initial cases you could start with, and all of these except this one actually lead to an answer. So I want to say it's not too bad actually. If you just prune, I want to say if you just prune the depth first search, you'd be okay. Just a little weird. Like I don't know if I could like prove that this would be manageable and reasonable time. It's kind of awkward. It's a pretty awkward question, in my opinion, but that's okay. We'll do a DFS as well. So let's see, how do we want to code this? We want to specify whether we've already picked a particular value. Just thinking, how do we do this? We could use a bit set. I guess that's fine. Practice using bit sets. So okay. There should be a get here, right? You can use actually this operator. So you can actually write to it using, oh yeah, that's interesting. I like that. It's kind of like an array. All right, let's say 15, and we'll say used, or yeah, we'll say used. And then we're going to say, it's going to be a little bit complicated because we don't know if we return a Boolean or not. I gotta think about this. This is going to be a little bit complicated because it's got three pieces to it. It's going to be a little bit complicated because it has three pieces to it, and I think it's okay. So we can have int target, int count, and then we also have, I think that's it actually. Like the bit set, you can make this a reference here, but it doesn't need to be. This is sort of like the state, I suppose. And the target is going to be total divided by 4, and count is going to be 3. And we just say terminate early if total modulo 4 is not equal to 0. Return false. Or it's not divisible by 4, then it's just immediately false. Okay. And we're going to say base case. There's a base case, and there's also a the recursive case, which is for something like this. We'll do int I equals 0, I is less than 15. We actually can say it's actually not 15. It's going to be Matchsticks that size. Okay. So what we're going to do, and there's a return value here. The base case, it's going to be kind of interesting. So we're going to do bool ret false. Yeah, so base case is going to look like this. If target equals 0, for base cases, it should be less than or equal to 0. It should be really equal to 0. If we could do it this way, we could say if target is less than 0, return false. Else if target equals 0. So if you're less than 0, then that's a branch that's not going to work, right? If you're equal to 0, that's a branch that could work. If you're greater than 0, then you keep iterating, keep selecting more matches. If you're equal to 0, then you say if count. So we're gonna decrement the count. We'd say if count is equal to 0. So that's actually a good question. So we want to do 3 matchsticks, right? One time we got true, we got 1 group, 2 groups, 3rd group. Once you get to the 3rd group, so you would decrement the count each time. You decrement the count each time, and now once the 3rd group has been defined, then you're done. So if count is 0, you return true. You actually don't return true. You would return. It's a sum over all of the remaining values. What's left? The matchsticks that are left. Then it's necessarily true. I think so. Yeah, because we checked already that the total can be broken into 4 pieces. So this last the last matchstick can be built that way. It has to be necessarily. So it just returns true, I think, at this point. Yeah. And then what we're going to say is, for each matchsticks, we say if, we're going to say if used of I hasn't been used, and we're going to use it. We're going to say used of I equals true, and F, so we just make this F, I think. F of F and some other parameters, and then used of I equals false. And we're going to say ret or equals. So if you can solve the problem from this point, then you get if it's possible to solve the problem from that point. So if you could find a solution after selecting that point, that'll set ret to true, and you end up returning true at the end of this. If you can't solve it at any point, yeah, I think it's an or. I think it's that's correct. And then the target is going to be, we're going to modify the target. That's going to be minus the value, so matchstick of I, and count should be the same. Now what's interesting here is you decrement the count and keep going. Now what I'm wondering is this value the same as this? Yeah, it is. Yeah, if you go to target 0, count, decrement count, and then otherwise, by the way, you'd reset the target to total over 4. Right, I missed that part. So you have to reset your target, decrement your count, reset your target, and keep going. Yeah, something like this. And interesting. It's something like this. I don't actually know. For some reason, this seems a bit odd. Compile error. For some reason this doesn't seem right. I don't know why. I gotta think about it a little bit more. I think there's something missing something here. Could try throwing in some random test cases. These are some pretty big numbers, man. I don't know. Let's see what we get with that. How long have we been on this? 40 minutes? Okay. Yeah, I mean, I spent a lot of time kind of just being really confused. Can we get a test case with... Is this right? Is that it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me try something with 15. right? 1, 2, 3, 1, 2, 3, 4, 5. Yeah. Okay. I don't want to time out. That's what I'm concerned about, timing out. Okay. And now, what else do we have? Yeah, we have an empty test. No, not empty. Yeah, I think the number of matchsticks has to be at least. The number of matchsticks has to be at least 4. Right? I guess that's another question. Time limit exceeded. Whoa. Uh-oh. Uh-oh. I think that would handle those cases. Oh, no kidding. Really? Wow. Alright. I think it's this one that's causing the time limit to exceed, by the way. Yeah. I don't think it's the other ones. I think these ones are fine. I think these all just fail for the most part. Yeah. But this one indeed. Now why doesn't this one work properly? This one TLEs. Let's think about it. How do we speed this up? Well, we get this total accumulated. We have this bit set. Hasn't been used. Set it to used. So we select a 1. What's the sum from 1 to 15? I think it's 16 divided by 2 times 15. 120. Okay. So 120 divided by 4 is 30. So we have 30, and we're going to take off 1, take off 2, take off 3, take off 4, take off 5, take off 6, take off 7, and that's no good. Interesting. Huh. I want to create like a set somehow to quickly, instead of having to go through all 15 values every time, quickly get a value that we haven't used yet. I mean, we could literally use an unordered set, but I think it's probably slower to do it that way. We could try it, see how it goes. I think it's a little bit better than a bit set. Maybe, possibly, hopefully, I don't know. I don't actually know if this part works. Yeah. Oh no. Oh. That's awkward too. Yeah, because you I don't know if this works. Actually, I don't know. I think it has to be an ordered set to do it the way I'd like to do it. You can remove the value from the set, the unordered set, and then you can place it back in. Mm-hmm. Oh no. Oh no. Also, a problem with this is that there are a number of numbers, I guess. You could have duplicates. Actually, that would speed things up quite a bit. Would that be better? Unordered map of numbers, like building a frequency map and operating over the frequency map. I think that would speed things up a bit. I think so. Well, we can't just use an unordered set. That won't work. I think we need to use an unordered map. Sure. Yeah. And then we won't be using, let's see what happens if we use a map. We'll be using the bit set. Sure. I mean, is this the same thing? Does it compile is the real question. More importantly, does it compile? More importantly, does it compile? Ah. Still TLEs. Why does it work on other solutions? I think it might. It just might. Oh wow. Extremely efficient on the other solutions. But not efficient, still not efficient enough on this one. Now, the answer might be to actually reverse sort this to speed it up. Okay. Yeah. Say reversed. Actually, yeah. Actually, it doesn't matter, right? The frequency map is what we're using. So, is there a way to sort the frequency map? Can you do that? I don't know that you can. I don't know if you can. You can maybe an unordered set. No, an ordered map, or just a regular map. And that could have a sort based on the frequency. Could do it that way. In theory, this would be slower. Interesting. Okay. Now what we want to do is reverse sort this map. So, see if that works. Compare, key, T, compare. Can we do standard less, standard greater? Yeah, let's try that. Okay. How about this? What does this look like? What does this do? Is that better? Oh, up, 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 a little faster, but we don't have the right test case in there. I think this will be faster. And I'm wrong. And I'm wrong. No. No. Okay. Hmm. Alright, could try something else. We can say something like this. And we can say if p.second equals 0, we could frequency dot remove pointer. And we can say we could do something like this. Something like this. This is kind of what I want to say. So you have destructuring of the pair to A and B, and then you'd make the pair again to insert it afterwards. You decrement B, and you have B++. If B is 0, you're going to remove altogether. I think this will make things a little bit more efficient, hopefully. That's my hope. There is insert, erase is what we're looking for. I want to ensure that insert gives us an iterator. Okay. It does. Yeah, that's what we want. Okay. Alright, what does this look like? Does it compile? Let's start with that. No. Auto, okay. Character P. That's A. That is just A. No variable overloaded equals constant in bool treater const. Really? No known conversion from value type pair, standard map, int, greater int, allocator, constant int iterator, boolean k, standard pair, to tree iterator pair constant int first argument. What is the issue here? Pair iterator insert. Oh, I see. Value type value. Ah, I got it. Interesting. Okay, a little confusing, but I think I understand. So one issue is, I would say if b equals 1, then and this is actually going to be this is actually going to be a pair, and we want the first, which is very confusing, but this is what it is, or can be otherwise. So frequency of A to B, which is 1. Oh, no, not 1, just not 1, yeah. If you add 1 to B with 0, then we have to add this back and set our pointer, otherwise we just increment frequency. Interesting. Interesting. Something like this is what we're after. And I really should use the other test cases. Still TLEs. No kidding. Really? Runtime error. Okay. No. Come on. Okay. Excuse me. Oh, it's not const auto. Okay. That's wrong. So, wow, what did I do? How did this happen? That doesn't seem to make very much sense. What? Excuse me. We can actually make these const and not just one. I don't think this solves our problem though. Yeah, that's a little weird. I wasn't expecting a runtime error here. Why though? Why would this begin and excuse me. P is greater than 0. If it's equal to 1, we want to erase this pointer. Otherwise, we decrement. We modify this pointer. It's not a const pointer. When does this runtime error occur and why? I mean, you can just say, this is probably easier to just say frequency of A is equal to B minus 1. Right, wouldn't that be better? What is the issue? I don't understand. I don't understand. Something like this. Oh. Okay. Wow. That's a lot more expensive. That's significantly worse. That is significantly worse. Why is this so slow? What is going on? Excuse me. Excuse me. Okay. Huh. I guess where this pointer is pointing to could be modified later. I guess that's the problem. How about that? Time limit exceeded. Interesting. Wow. I don't know what I did. I don't know why this is so much slower. This is really slow. This is really slow. Huh. No kidding. The regular unordered map was a lot faster. I don't know what to make of this. This is what I had before. This seems pretty good. Seemed pretty good. I got 0 milliseconds for these solutions. Oops. How about the last one? TLE. No! Why is so difficult? 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 I don't know, man. I was thinking just a simple DFS would do it. Frequency map with some selections, but nope, not fast enough. And why? I don't know. Well, I mean, you said this is 15 times 8 divided by 4. It's 30, square root of 30. It's 5. Let's say 6 factorial. This shouldn't be that bad, you know? This really shouldn't be bad at all. I don't know, man. Maybe I need maybe I need to use maybe I need to memorize this somehow. Like what I had before with the bit sets, or there was a different DFS related question where I had the memoization was set up properly, and it was efficient enough. Maybe I need to do the same thing. Maybe that's the problem. This just needs to be memoized. In other words, once you've made a certain selection, like there's a few different ways to reach the same selection, and you don't need to do that work over and over again. Like you don't need to repeat the whole subtree from that selection once you've made it. I think that's what I want to say. I think, yeah, there's a few different ways to get to the same to select the matches that you're going to select. So memo-wise on what's left over, I think. Yeah. Creating like a hash of the bit set. I think that's what I need to do. I need to go back to a bit set and then hash on the bit set and memo-wise on the bit set. Do it that way. Yeah, let's do that way. I like that. All right, let's go all the way back to the going way back, but all the way back to when I was using a bit set. I'll show you why. All right, is this correct? Does this function? Does this work? DLE's here. Okay. So it's significantly slower than the frequency map solution. And I think, I don't really know why that's the case. I think the reason is because the frequency map is different from the, there's a couple problems here. So one problem is the frequency map is different from the bit set in that it's a little more challenging to hash the frequency map. Although I guess it could be done. The bit set, on the other hand, has a built-in hash. But the difference is the bit set, we're going through all 15 numbers as if they're all totally different from each other, which is different from the frequency map where you have copies of values in the frequency map. So I think we should actually use the frequency map, but we want to memoize the frequency map somehow. Yeah. Which I think is doable, actually. Creating a hash map of a hash map. That's pretty interesting. I mean, we could try it, see how it goes. I don't really know. Can you hash a pair? No. No, the pair hash is a special thing going on. Interesting. Do hashes have an equal to unordered maps have an equals? I wanna take this frequency map and hash it. Assigns value to the container. Yeah, compares the values. The contents of the containers are equal. Okay. Cool. So we can. All right. Sweet. All right. Let's try that. Let's go back to our. All right. Have an idea. I don't need to reverse anything. Does this one work? All right. So we're going to memoize as well. You ready for this? It's going to be an unordered map of unordered maps. Of int to int frequency maps. And we're going to call this the memo function. And it's going to be mapped to booleans. And then we need a hash for our unordered map. Probably could use a regular map, actually, now I'm thinking about it. I wonder if that works. Curious if we could do this. Just keep it simple for now. Come back to this. Okay. Does this compile? Oh, it does. Okay, that's interesting. We're just gonna use this for now. We can come up with our own hash in a moment, but let's just try the regular map first. We'll just say if. So we have an unordered map. We're going to have also the target and the count. I think also is what we want. Does it really matter what the target and the count are? I think it does. Yeah, I think it does. I think we need a tuple. Int, and then unordered map. How about that? How about that? We need all the inputs. We need the target, the count, and the map. Compiler. Oh yeah, okay. Does that work? Okay, interesting. So if memo of standard make, so we're gonna say key, auto key equals standard make tuple of target, count, and frequency map. Say if memo of key dot count is, or memo dot count of key is greater than 0, return memo of key. Right, and then here we're going to say memo of key equals false, turn false, key equals true, turn true. Ret, we say memo of key equals ret, turn ret. Alright, how about this now? Does this work? Oh boy. That's too funny. Alright, what's the problem? Excuse me. Int unordered map. So I guess the issue is, how do you compare these keys to each other? What is? Look at this! Look at this error, this compiler error. This is crazy. Also, wow, we spent a lot of time already. It's time for me to go to bed. Actually, I need sleep. I need sleep. Oh, okay. And file included from functional invalid operands to binary expression, tuple element, hash, unordered map, and const standard get less than standard get. Instantiation of member function less requested here. Okay. So I guess there's no way to compare the tuples to each other. I guess that's the problem. Because you don't have a way to compare unordered maps to each other. I guess that's the problem. Can we just use can we use a regular map? Can we compare these to each other? Yeah, you can do. That's funny. So we don't have a less than. Okay, well, that's interesting. So this doesn't actually work the way that I would have liked it to. But what you can do is just change this to a map. How about that? How about that? Oh, still works. Slightly slower, I guess. But now it looks like we're memoized, which might be better. Might be better. See if it's better. We'll see about that. Oh, no, come on. Please, please. Disappointment. I don't know, man. I don't know, man. Could also terminate early, I think. Maybe that's what we need to do. Maybe that's the problem. Need to terminate early in there. Oh, there we go. Hey, that's all we needed. Okay. Probably didn't need all this memoization either. I'd be willing to bet. Let's go all the way back. Actually, hold on. Let me do this. Let's go all the way forward and just save this somewhere. Hold on a second here. Alrighty. Yeah, now go back. Now we go back. Okay, so we run this now. Oh, wow. Okay. Do we go for it? I think we go for it. Yeah, so that's all you really needed. You didn't need to memorize anything. Nice. Okay. I think we just go for it. I'm afraid to, but we're doing it. Hey, got there. Wow. Okay, that was not cheap. All right, we did it, but it took us an hour and a half, and I mean, it's not too bad. Like, as far as the code, like, this is super simple, really straightforward thing. Could have done this a lot faster. Could have probably done this in like 15 minutes if I really thought about it and just kind of went for it, I guess. Not went for it, but if I did this differently, I think this could have been better, I suppose. Now, if we try to memoize this, I wonder if that helps at all. I'm very curious to see if we can memoize this and make this a lot faster. Actually, let's save this as another one as well. Okay. This one looks slower. Significantly slower. Okay. It's significantly slower. Alright. Used a lot more memory and is way slower. Someone said they had 6 milliseconds on this test case. I don't know, they did that. I didn't get that. I didn't do that well. So yeah, the simpler code seems to be superior. Interesting. Wouldn't have expected that. You may be able to speed this up by memoizing like the unordered map directly. There's probably some pruning that could be done here to make this faster that I'm missing. Yeah. This is obviously part of the pruning. Terminating early. Terminating early. All right, let me go from here. This is pretty straightforward, I think. Yeah, this is something that I could have written really a lot faster, I think. The solution. It's not the best solution though. It's pretty far from the best. Someone in the discussion said they had 6 milliseconds. I think I'm going to leave it at here though. I kind of want to just go to bed. I'm going to yeah, end it here and then cut the video because end it here and cut the video because I want to go to sleep. End it here, cut the video. There's one part of the video I want to remove. Go to bed. Just thinking, what else do I want to say or talk about or do? I think I need more practice. Maybe? I don't know. Just remember to terminate early, I guess. Like, yeah, that was not a hard. That wasn't hard at all, or shouldn't have been hard at all. That should have been pretty quick. Probably could have done that in 15 minutes. I don't know. Something about the DFS questions. It's like can be challenging because you're kind of concerned about the time limits. But that was fine. That was okay. All right, I'm gonna go. Thank you for watching. I will talk to you soon. Have a good rest of your day, and yeah, take care. Bye.